Hello. All right, so I'm going to go over, I guess, 11 through 15 in this video. Right, my last video I did 1 through 10. All right, so number 11 asks, for which of the following integers b is the base b number 2021 base b minus 2221 base b not divisible by 3? Okay, so for anyone who doesn't understand what bases are, it's a little tricky, but it's not terrible. So like most, the numbers that we deal with regularly in our lives are base 10. So, when we write a number like 326, right? And we just know what that means, but it's technically in base 10 even though we don't write base 10. And what that means is that every space is a power of 10. So, right, it's 6 times 10 to the 0 power because, right, it's 6 times 1. But the 2 is actually times 10 to the 1 power, right, which makes it 20. And the 3, oh, come on. The 3 is times 10 squared to make it 300. So, right, so each digit, each number is in a specific place, right, like a decimal position, right? And then if I added a 4 here, that would be plus 4 times 10 cubed, right? 5 times 10 to the third or fourth, or et cetera, et cetera. So like, right, so that our numbers are based on powers of 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, et cetera, right? And even as you get into decimals, it's going to be point, and then it's going to be 10 to the minus 1, 10 to the minus 2, right? And that's how we'll get our numbers in base 10. But you can also work in non-decimal bases, right? One of the more commonly known ones is what's called binary. So binary is numbers that are written entirely out of ones and zeros, right? And anyone who does like computer programming might recognize something like that. And this little 2 here means that this number's in binary, which means everything's based on powers of 2. So this would basically be 1 plus 1 times 2 plus 1 times 2 squared plus 0 times 2 cubed plus 0 times 2 to the 4 plus 0 times 2 to the 5 plus 1 times 2 to the 6, etc., right? So that would be 1 plus 2 plus 4 plus 0 plus 0 plus 0 plus, right? That's 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6 plus 64 plus 128 plus 0 plus 256, 512, right? And then you would just add this up, and that would give you the base 10 version of that number, right? So that would be base 2. So this question's saying, well, what about if we're just in some base b, and we don't know what b is, right? But we know that the number 2021 base b minus 221 base b is not divisible by 3 in base 10, right? So the 3 is now in base 10, right? So we should convert these numbers into base 10, right? Which we would do by taking this and saying, well, that's 1 times b to the 0, which is just 1, right? Plus 2 times b plus 0 times b squared plus 2 times b cubed, right? That's the first number in base 10, right? So it's basically 2b cubed plus 2b plus 1, right? The second one would be 1 plus 2b plus 2b squared. Okay? Now, if we subtract these two numbers, right, we would get 2b cubed. This would cancel with this would cancel with this. So we'd end up with just 2b cubed minus 2b squared, or 2b squared times b minus 1, right? And we're told that this number is not divisible by 3, right? So what does that mean? Well, that means that Well, think about it. For this number to not be divisible by 3, well, definitely b can't be divisible by 3, right? So b cannot be a multiple of 3, right? And at the same time, b minus 1 can also not be a multiple of 3. So b minus 1 cannot equal, let's say, 3k, where k is an integer, right? And b itself can also not equal, let's say, 3 times m, where m is some integer. But the second one tells you that b does not equal 3k plus 1. So what does this mean? This means that b cannot be a multiple of 3, and it also cannot be a multiple of 3 plus 1, right? It can't be a multiple of 3, and it can't be a multiple of 3 plus 1. It can't be a multiple of 3 plus 1. So the only other option is it's a multiple of 3 minus 1, right? Or multiple 3 plus 2 is the same thing. So the only other option is a multiple of 3 minus 1. Well, which answer choice is a multiple of 3 minus 1? Well, 3 is a multiple of 3, 4 is a multiple of 3 plus 1, 6 is a multiple of 3, 7 is a multiple of 3 plus 1, 8 is a multiple of 3, 9 minus 1, right? So the answer is E, 8. So this one would have been hard if you've never worked with non-decimal bases before, right? So I could understand maybe you skipped this one if you did not know what that meant by base B number. So maybe you want to like go and study a little bit about base B non-decimal bases, right? You can find a lot of good stuff on YouTube. So all right, number 12. Number 12 I did a lot of work for. So yeah, this one I did a lot of work for. Okay, so it says 2 right circular cones with vertices facing down as shown in the figure below contain the same amount of liquid. The radii at the tops of the liquid surfaces are 3 centimeters and 6 centimeters. Into each cone is dropped a spherical marble of radius 1, which sinks to the bottom and is completely submerged without spilling any liquid. What is the ratio of the rise of the liquid level in the narrow cone to the rise of liquid level in the wide cone? Okay. All right. So we need to think about how this is going to work out. Yeah, okay. So we know the radius of this one's the radius over here is 3, the radius over here is 6. We can call the height of this one like h1. Whoops. It always does it the first time I draw something. We can call this h1, we can call this h2, right? We know that the volumes are the same, right? And we know that the volume of a cone is 1/3 pi r squared h, right? It's basically 1/3 the volume of a cylinder, right? So notice how the volume on the left would be 1/3 pi 3 squared h1, right? And the volume on the right would be 1/3 pi 6 squared h2. And they're equal, right? We can set these equal, but then notice how the 1/3 pi will cancel. So we're left with 9h1 equals 36h2. 9h1 equals 36h2, or h1 equals 4h2. So what we come out of from that is that h1 equals 4h2. Right? Yeah, so the height in the left one is equal to 4 times the height in the right one. So now we're adding a marble of radius 1 into this, right? So each one will increase their volumes by 1. Right? But now let's think about this. If this one goes up by any amount, right? If the amount of liquid in the left cylinder or lift cone goes up at all, right? It's gonna, obviously maybe it's now up to here, right? And it's now gonna be like this. But notice how the triangle that's formed here is similar, right? So the ratio of 3 to whatever h1 is going to be still equal to the ratio of whatever the new radius is to whatever the new height is, which I'll call h1 new, right? And I'll call this r1. And then same thing on the right. So 6 divided by h2, which remember is 4h1, right, will be equal to the new radius wherever it ends up, right? Divided by the new height, right? Because this is h2, and then this will be h2 new, right? Sorry, I'm trying to write the word new. Right. So, and we essentially want the ratio of those. But then the question becomes, do we know that no matter what, as long as the volumes of the two liquids are equal, will the radius on the right always be double the radius on the left? Well, we do know that the height of the left one is equal to 4 times the height on the right one, and that was just purely given the fact that the volumes were equal. And after adding the marble to each one, their volumes are still equal, which means that height is still in that same ratio, right? So the new height on the right, or sorry, the new height on the left is still going to be equal to 4 times the new height on the right. Okay. But then, but remember that the original height of the left one is also 4 times the original height of the second one. So if I do h1 new minus h1, which is basically delta h1, right? Well, that's going to be equal to 4h2 new minus 4h2, or 4h2 new. I'm just going to write n minus h2. Sorry, that's h2. Or 4 delta h2. So the rise in height of the left is going to be equal to 4 times the rise of height in the right. So the ratio of the liquid rise in the left narrow cone to the rise of liquid level in the wider cone is going to be 4 to 1. Yeah, I did so much work for this question. So much work. And what it really comes down to is the idea that, like, remember the whole fact, because remember, they don't give us any volumes. We don't know any specific volumes. We don't know the heights of these two things. All we know is the ratio of their radii, right? And remember, we find that the height of this being 4 times the height of this purely from the fact that their volumes are equal. And after adding the 1 centimeter marble, which they could have made 100 centimeters, doesn't matter, right? The volume is still equal, which means the height over here is still 4 times the height over here. So that means that the height change here is equal to 4 times the height change here. So that's why the rise of liquid level over here is 4 times the rise of liquid level over here. Yeah, this question's pretty annoying. All right, anyway, I'm going to move on. So the answer is E, okay? All right. Whoops. 13. What is the volume? Oh, yeah, I had trouble drawing this one. I remember I had a lot of trouble just figuring out what this thing looks like. Okay. So we have what's called a tetrahedron, right? A tetrahedron is a pyramid with a triangular base, right? A tetrahedron is a pyramid with a triangular base. ABCD with edge lengths AB is 2, AC is 3, AD is 4. BC is root 13, BD is 2 root 5, and CD is 5. Okay. So the first thing I noticed is that so a lot of times when you look at these, right? Like obviously without a calculator, you really need to be dealing with right triangles. Or equilateral triangles or something that's easy to deal with, right? So if you look at AB is 2, AC is 3, and AB is 2, AC is 3, and BC is root 13. 2, 3, root 13 is a Pythagorean triple because 2 squared plus 3 squared equals root 13 squared. 4 plus 9 equals 13. So that means we have a right triangle there. So if I draw a triangle, so I'll make this BC and this is A, right? This is 3, 2, root 13. This is a right triangle, right? So now, now what about D? So D, okay. 3, 5, 3 and 5. So that's gonna be 9. 9 and 25 makes 34. So that's not a right triangle, but 3, 4, 5. Oh, we also have 3, 4, 5. Because AD is 4 and CD is 5. AD is 4, CD is 5. So that means that like it's going to be really hard to draw and you're going to kind of have to bear with me here. But if I were to cuz what is it? CD is 5. So I could kind of extend this up and extend this up. And then this distance, this is D, right? This is 5. AD is 4, right? That's 3, but that's a 3, 4, 5 right triangle. So this angle is also 90 degrees. But D is like up in the air, right? This is not in a plane, right? D is like up, right? And then BD has length 2 root 5. So this is 2 root 5. So I'm gonna try to draw this a little bit better because I want to kind of give a better sense of how this is supposed to look. So I'm trying to think how to draw this. So if I draw like this, and then this one's like up, right? And then it's pretty hard to draw no matter how I do it. You have to kind of picture it. Well, I guess I can. Yeah, there's really no easy way to draw it. But basically, like D is up here, right? And then you have D. Which one's 5? DC is 5, right? And then DB is 2 root 5. And DA is 4, right? So that's 4. DC is 5. But AC is 3. So that's 3, 4, 5. Right. So it's sorry. Yeah. Okay. So yeah, I had drawn it right over there. Yeah. So I almost well. Yeah. I don't exactly know how to draw this in a way that's like reasonable. If we make this angle 90 degrees, right, and that's so which one's 90? So it's A. Sorry, I'm just trying to label them properly. So if we call this A, right, then that's BC, and BC has length root 13. AC has length 3. AB has length 2. D is up here. CD is 5. AD is 4 and BD is 2 root 5. So this angle is also 90. Okay. So then, okay, the way you can find what's nice about that is that means that AD is actually the height of the tetrahedron because AD is perpendicular to AC, which is on the base. So that means AD is the height. So the way you find the height of like any type of prism, which this is a prism, right, is essentially by doing it's going to be of a pyramid specifically is 1/3 the area of the base times the height of the pyramid. Right? Yeah. Yeah, it's going to be 1/3. So it's going to be 1/3 times. So the base is a triangle with sides 2 and 3. So half 2 by 3 would be 3, right? And then the height is AD, which is 4. So you just get 1/3 times 3 times 4, which would just be 4. So the answer is C. Right? So this one you have to be able to draw. That's the key thing for this one. You have to be able to draw it. Okay? If you can't, then you're going to really struggle with this. And like I said, I struggle with drawing it. So, right, in order to be able to sort of visualize what exactly you're dealing with. Okay? All right. Next one. 14. All the roots of polynomial z to the 6 minus 10z to the 5 plus az to the 4 plus bz to the 3 plus cz squared plus dz plus 16 are positive integers, possibly repeated. What is the value of b? Okay. So, one of the things you learn about, especially in like IB math, is when you're dealing with polynomials, right? A lot of times you're dealing with the sum of the roots or the product of the roots or things of that nature, right? So, and some of them may be imaginary, some of them may be complex numbers, right? But in this case, we're told that all of them are positive integers. So, and because it's a sixth, because it's a how would I say it, a sixth power polynomial, order 6. I'm forgetting the word. It's an order 6 polynomial, I think. So that means that it's going to have 6 roots, right? So it's going to be, so we can call the roots like, oops, no. We can call the roots z1, z2, z3. Whoa, that's not a good 2. z4, z5, and z6, right? And we know that they're positive integers, right? Now, one thing we know that the constant term is 16. And if you think about it, if you take like, because remember, like you would have like z minus z1 times z minus z2 times z minus z3, and like you would have a bunch of these. That's a minus sign, sorry. Z minus, and then like, right, and that would give you the polynomial. So notice how like when you multiply, you're gonna have z1 times z2 times z3 times z4 times z5 times z6 is going to multiply. That's going to give you the constant term. Well, it would be minus z1 times minus z2, but since there's 6 of them, right, the minuses will basically cancel out. So what that means is that the product of the roots, z1, z2, z3, z4, z5, z6, right, equals 16. So the product of the roots is 16, right? Now, what about that minus 10 up there, right? That minus 10 must be there for a reason. Well, one of the other kind of rules that you have, I think these are called Vietta's formulas. So one of the other rules that you have when it comes to polynomials is that the sum of the roots, right? The sum of the roots, z1 plus z2 plus z3 plus z4, has to equal the negative of the second coefficient after the leading one, divided by the leading coefficient. So in this case, like, because it's a 6th degree polynomial, so you say like, what's the second? So what's the coefficient of the 5th degree term, right? Would be negative 10, right? What's the coefficient of the highest degree term? 1. So that means that the sum of the roots is negative 10, right? So we know that if we were to add these roots together, we would get negative 10. Okay. So now, so we're adding a bunch of positive integers together that when they're added, Oh, sorry, it's negative 10 over 1. So it's actually positive 10. Okay. So what does that tell you? Z1 plus Z2 plus Z3 plus Z4 plus Z5 plus Z6 is 10, right? Oh, I have the hiccups. Well, what numbers, if you add them together, you're going to get 10, and if you multiply, you're going to get 16. Well, they need to be pretty small if there's 6 of them that are adding up to 10, right? They couldn't even all be 2s. That would add up to 12. So it's either 2s or 1s, right? And how many 2s make up 16? 4 of them, right? So 2 to the 4 is 16. So could they be 1, 1, 2, 2, 2, 2? Right? Will that work? Because then if we do 1 times 1 times 2 times 2 times 2 times 2, we get 16. If we do 1 plus 2, 1 plus 1 plus 2 plus 2 plus 2 plus 2, we get 10. So those must be the roots, right? Okay. So that means the roots of this polynomial are 1, 1, 2, 2, 2, 2. Okay, so now the question asks, what is the value of b? So b is the coefficient of the cube term, the third degree term, right? So, okay, we know that we basically have something that's of the form z minus 1, I already had a 1 there, z minus 1 times z minus 1 times z minus 2 times z minus 2 times z minus 2 times z minus 2, right? And we want to know what term we'll get, what coefficient we'll get in front of the z cubed term. So let's just think about what combinations of numbers are going to give us z cubed. So for example, if we multiplied the first 3, we'd have z times z times z, but then we're going to need to take numbers over here because we don't want any more z's. So that would give us -2 times -2 times -2, which would give us -8, right? But we could also take this one, and this one, and also we'd still get -8. So we need like a more systematic way to do this. So maybe what we could do is we can think about it in terms of how many ones we're going to take. So let's start by saying, what if we don't use any ones, right? We're only going to use 2s. Well, how many ways can that be done? Well, there's 4 2s to choose from, and we want to choose 3 of them, right? So we essentially want to do 4 choose 3, right? We basically want to do 4 choose 3 to give us all 2s, right? But 4 choose 3 is just 4. So there's 4 ways that would allow us to pick all the 2s, which would give us -8, right? Because -2 times -2 times -2 is -8. Now, what if we wanted 2 2s and 1 1, right? So if we wanted 2 2s and 1 1, well, there's 4 2s, choose 2, and there's 2 1s, choose 1. 4 choose 2 is 4 times 3 over 2, which is 6, right? 6 times 2 is 12. So there's 12 ways to do that, and if we use 2 2s and 1 1, we get -4, right? So then the only other possibility is if we use 1 2 and both of the ones, right? So if we use, right, because the first one is basically no ones, the second one is 1 1, the third one is 2 ones, which are your only possibilities. So if we're going to use both the ones, we're just going to use both of them. Then we just need to choose one of the 4 2s. 4 choose 1 is 4, and using 2 1s and a 2 would give us -2. So we have to do 4 times -8 plus 12, plus 12 times -4 plus 4 times -2. -32 minus 48. -32 minus 40 is -80. -80 minus 8 would be -88, right? So I think the answer for number 14 would be A, -88. Okay? So the answer for number 14 is A, -88. All right. Okay, and then 15, which I struggled a lot with number 15. I struggled a whole heck of a lot. Until I realized something that made it a lot easier. So the question says values for A, B, C, A, B, C, and D are to be selected from 1, 2, 3, 4, 5, 6 without replacement, i.e. no two letters have the same value. How many ways are there to make such choices so that the two curves y equals ax squared plus b and y equals cx squared plus d intersect? The order in which the curves are listed does not matter. For example, the choices a equals 3, b equals 2, c equals 4, d equals 1 is considered the same as the choices a equals 4, b equals 1, c equals 3, d equals 2. So just swapping a, b with c, d does not create a different scenario because you're just swapping the two curves, and it's the same thing. Okay, so we need to choose 4 integers from 1, 2, 3, 4, 5, 6 in such a way that, and as a, b, c, and d in such a way that the function ax squared plus b will intersect with cx squared plus d. So let's find out what conditions need to be met for that to even happen. So in order for that to work, ax squared plus b has to equal cx squared plus d, right? But that means that ax squared minus cx squared has to equal d minus b, which means a minus cx squared equals d minus b, or x squared equals d minus b over a minus c, right? So now let's think about this. We need this to be real values, right? We're talking about real numbers here for x. If we square any of these numbers 1, 2, 3, 4, 5, or 6, we will get a positive whole number. So we need to make sure that this would actually work. So the only way for this to make any sense is if d minus b over a minus c is positive, right? D minus b over a minus c needs to be positive. And how can a fraction be positive? A fraction is positive if either the numerator and denominator are both positive, or that's a 0. Sorry. Either both positive or they are both negative. Okay, so the only way that happens is if numerator and denominator are either both positive or both negative, right? And in the first case, right, case 1, that just means D is bigger than B and A is bigger than C, right? Okay, does that make sense? So, right, and then we would look at the second case, but it turns out that the second case is basically the first case, but with the letters A, B swapped with C and D. Because in the second case, what ends up happening is D is less than B and A is less than C. Right? Which basically just swaps A with C and B with D. Right? If you think about it, like it's just swapping them around. It's just reversing A to C and B to D, which switches the inequality symbol, right? But remember how we said that just switching A with C and B with D does not create a new scenario. So we only need to consider one of these cases. So we can just look at the case where B is greater than D and A is greater than C, right? Well, basically all that requires is, remember, we're picking 4 numbers, right? So let's start by, for D and B, we can basically just pick any 2 of them, right? We can do 6 choose 2, right? And every pair is going to create one that's smaller and one that's bigger. So it'll automatically determine which one's B and which one is D, right? So the 6 choose 2 will just automatically determine a B and a D, right? The bigger one just becomes D. That's it, right? And then from the remaining 4, we just pick another 2. And then they, again, one will be bigger, one will be smaller. The bigger one will be A, right? So by doing 6 choose 2 times 4 choose 2, that should give us the number of ways to pick basically A, B, C, and D, right? 6 choose 2 is 3 times 5, 15. 4 choose 2 is 2 times 3, 6. 15 times 6 is that 90? 30. 30 times 3 is 90, right? So the answer is C. The tricky part for me was understanding why we didn't have to consider the second case. But basically it just what ends up happening is like it's essentially the same cases just switched around. It's basically just a scenario where B is less than D and C is D is less than B and A is less than C, which basically just takes the two curves that you would generate over here and just swaps them around, right? Which is going to be just repeats. They're going to be the same things just switched. So that's why you don't have like 180 choices. You only have 90. Right? So you have to take a little time to convince that to yourself why the second case ends up being redundant. You don't even need to consider it. All right? Think about this condition that they gave at the end here. So all right, I think I'm going to end the video here. Okay? I hope these are helping you guys. And I'll see you soon.